Welcome to part 2 of adding and subtracting rational expressions. In this video, we're going to go a little bit more quickly. We have already introduced the basics of the four-step process of adding and simplifying fractions. And then we've talked about how we go about finding a common denominator. So we're just going to pick up right where we left off with we'll start with 16. So 16, anytime I see a problem like this, I like rewriting it with a little bit more of extended fraction. The bar that goes across. So then I have 4 and then n plus 1, okay? Now, the reason why I do this, and let me change the color here of this one. Let's change it to green. Now, what I'm going to do is I notice that we do not have a common denominator, so I really want to multiply the two denominators together. So I really want there to be an n plus 1 there, and then an n plus 8 over here. But you can't just put it there without also doing it to the top to keep the fraction equivalent. Otherwise, you're going to be changing the value if you just multiply the bottom. So you have to multiply the top and the bottom for both of those. So really what we're going to do is we're changing how these two fractions look so that we can add them together in just a little bit with a common denominator. So this changes to, I'm going to leave this as n plus 8, n plus 1 for now. I may change it later, and then we have 4 and then n plus 8 over n plus 1 times n plus 8. What I'm going to do is I'm going to go ahead and leave the denominator the same. So again, n plus 8, n plus 1, that's the same. That's the common denominator we were looking for, okay? Now on the top, what I'm going to do is I'm going to distribute both of these and add them in the top of this fraction. Okay, so I'm going to use green here to distribute. If I distribute that, I get 2n plus 2. And then I have a plus sign here between the two fractions. So I'm not going to distribute any negatives here. It's just going to be positive. And then it's going to be positive 4n plus 32. Now I'm going to look for any other like terms. So in this case, I have more like terms. I have 2n and 4n, which are like. And then I'm going to have 2 and 32, which are going to be like. Doing the first ones gives me 6n, and then the second ones gives me 34 plus 34, and that's going to be over my original, which was n plus 8 and then n plus 1. It doesn't look like I can break this down any further. I can't simplify 34 and 6 other than dividing by 2, which really doesn't help me because I would get 2n plus 17 and then n plus 8 times n plus 1. So that there's nothing more to cancel here is what I'm trying to say. So this is the most reduced it can be. Now, sometimes your teacher may want you to expand the bottom. So our final answer would be, let me do purple, 6n plus 34 in the top, and in the bottom, expand this. So we have n squared plus, and what is that, 9n, after I do it both ways, plus 8. That might be the way your teacher likes to have it, but essentially both are equivalent. Let's go ahead and do maybe a tougher one. Let's do 21 looks pretty tough, so let's go ahead and look at this one. Now, the first thing I'm going to do is, this is kind of a trick. You might be tempted to find a common denominator first, but I recognize that I can simplify before finding a common denominator. So if you can simplify the fraction separately first, you might want to do that. So let me take a look here. First, look at this. You can cancel the n and the n right away. So I would go ahead and do that. So now we have plus 7 over 3, and that's much easier. Then what I'm going to do here is I'm going to factor out a 5 because I notice, let me different color. I can factor out a 5 because I see a factor of 5 in every one of these terms. So when I factor out the 5 in the top, I get 5 times n plus 1. And then when I factor out the 5 in the bottom, I get 5, and then n squared plus 7n minus 8. And then what I can do is I can cancel out those 5s just like I did with the 7s. So now I have a much easier problem, which is n plus 1 over n squared plus 7n minus 8. And actually, I'm going to factor that one. So I'm factoring this into binomial. You might want to check out one of my videos on how to do that if you're confused. But I'm getting it into n, n minus 1. Okay, and then we have plus 7 over 3. Now, what do I need to do here? Well, I see that I'm missing a 3 over here, and then I'm missing the n plus 8, n minus 1 over there. So I'm going to have to make sure I change both of these fractions so that they include both of the components of the denominators. I want to multiply the denominators together. And in order to do that, I also have to multiply the numerators. Let me show you how that looks. Well, first I need to multiply by 3 in the denominator. What I do to the bottom, I also have to do to the top. Put it in parentheses if there's addition or subtraction. Then with this other denominator, I need to multiply by n plus 8, n minus 1. What I do to the bottom, I also have to do to the top, n minus 1. Okay, now I got to simplify this a little bit. I'm going to simplify in purple. So I'm going to distribute 3n plus 3 on that one. And then in the bottom, I'm just going to leave this like this. 3 times n plus 8 times n minus 1. I'm going to leave it like that for now. This is plus, so that's good news. I don't have to distribute the negative sign, but I have a lot to distribute here. So I know that, well, I guess I could just go ahead and do it again. So I got to distribute. I'm going to do this distribution first, and actually when I do that, I get n squared plus 7n minus 8. And then I extended that a little bit. And then I also have that 7 I still have to distribute. So I need to distribute that 7 now to both of these, to all 3 of these actually. So that gives me, I'm going to change it to blue in the top. I get 3n plus 7, no, plus 3, sorry, plus 3, plus 7n squared, plus 49n minus 56. That's my numerator. So I'm going to simplify that in just a second, and then I keep it over my denominator, and I'm going to keep my denominator as 3 times n plus 8 over n minus 1. I'm going to keep it factored for now. Okay. Let's look for like terms. So let's go pink this time. So I have a 3n here and a 49n here. That's going to give me 52n. I have a 7n squared. That should go in front. 7n squared plus the 52n. And then I have a positive 3 and a negative 56. So that's going to give me a negative 53. And then I put that bar here. And then I have 3 times n plus 8 over n minus 1. Your teacher may want you to, again, simplify, not simplify, but expand the bottom. So then we would have 3 times, what was it, n squared plus 7n minus 8. And then just distribute there to all 3 to get 3n squared plus 3n squared plus 21n minus 24. That may be how your teacher wants it, but that is the expanded form. Okay, all right. I'm going to talk briefly on these ones right here. Let's do number 26. If we have something like this, a compound fraction, I have a different video on this, complex fractions. Go ahead and look it up. Essentially what we're going to do here is we're going to use the keep, change, flip philosophy, which is you keep the top fraction. You're going to change the division sign. That's the big one, separating the compound fractions. You're going to change this to multiplication. And then you're going to flip the bottom. Okay, simplify first though. So we're going to simplify this to 5 minus 4 over m because it already has a common denominator, which is great. Okay, so it becomes 1 over m. So now we're going to flip this. We changed to multiplication. We kept this the same. So let me actually change the color here. We kept this as 5 over 4. We changed this to multiplication, and now we're going to flip 1 over m to, where's that multiplication? Multiplication, and then we're going to flip 1 over m to m over 1. Remember, dividing is the same thing as multiplying by the reciprocal. So that's why we're just changing this purple to the reciprocal right here and then multiplying. Once I do this, I get 5m over 4, and that's my final answer. So it's as simple as that. You can also look at my complex fraction video for further details. Let's do these critical thinking problems real fast just in case you have a question on it. So we have 8 over b plus c over d. So clearly we just need to change this to times d here, and then times b over here to find a common denominator. So we have AD plus CB in the top, and then this is all over BD in the bottom, and that would be our final answer.